Hello, my name is Sierra, and in this video, I'm going to be presenting my final project for my permaculture design course. And the title of this design is a swamp backyard eco haven. And this site is located in Lake Charles, Louisiana. And the general idea of my design is rooted in regeneration and the cycles of life. This design transforms a swamp-influenced backyard into a closed-loop ecohaven, integrating food production, soil building, and household waste streams into ecological systems of renewal and resilience. That is a mouthful, and it sounds like a lot, but we are going to go through it bit by bit and bring it all together. So let's get into it. First off, a little bit about myself is my background is in environmental science and research. I pursued this field out of a genuine desire and care for the earth. I've always wanted to make things more sustainable and, make the world a better place. Most of my life, that was very abstract, and I sort of just went through the sciences because I was interested in earth sciences, and that's just what was the path available. So I just sort of followed that until I ended up in a research career. And then just last year, it deeply occurred to me that research and data alone is not going to bring about the kind of transformation that we truly need in the world at this time. So, throughout my entire life, I've been very connected to the natural world, and I would often, find a sense of peace there when I couldn't find that in other places in life. And as I've immersed myself more into nature over the years, I eventually learned how to identify and forage edible and medicinal plants, mushrooms, rocks, and minerals. And living in this relationship with the land has brought me from understanding into actually embodying these principles of nature, such as reciprocity, flow, and the cyclical harmonies. And all of these things are now what's guiding my design approach. And as I moved through academia, I never resonated with any defined career path. And like I said, I was just following along the path that was basically available to me. And what I did know is that my ideal work, I've always known that I just wanted to help basically transform land into something more sustainable and regenerative. And luckily, very early into my research career, I realized that I am meant to work towards making real world community based actions rather than basically just turning nature into more and more data to analyze. So today, my permaculture work is guided by these principles. I'm passionate about returning to the cycles that sustain us, closing loops, and working with the energetic architecture that is already present in order to bring about new ways of living. And my goal is to design systems that nourish people, communities, and the earth for the good of all. So let's get into my design. While there are many goals that are encompassed within this design, here are four top goals that I think sort of anchor a lot of the rest of the goals within this design. These are the smarter goals, which are specific, measurable, achievable, relevant, time-bound, ecological, and rewarding. So they just give us a very in-depth foundation to follow. These four main goals that I will be covering are a closed loop chicken system, near zero household waste, building soil fertility for gardens and guilds, and establishing perennial food producing guilds. So before we get into the specifics of these goals, I want to talk about the system that will actually enable all of these things and establish the powerhouse that is the chicken and black soldier fly system. So this part of the design is truly what will enable loops to actually be closed and for intensive production on this site. So the chickens, we start here, they convert their food, which includes the black soldier fly larvae, food scraps, and grains, into fertility for the gardens as well as food for humans. So their yield and services are eggs, meat, and nutrient-rich compost, as well as soil fertility, pest control, and aeration. So they directly benefit the plants and the guilds through the semi-permanent fencing that will be set up to create rotating foraging areas where the chickens will be able to directly interact with the soils and the guilds in those areas. And that fencing will be reoriented seasonally so that the chickens can rotate through the different foraging areas and interact with the soil in each section as appropriate. And so they are providing these direct mechanical benefits to the soil, as well as producing very nutrient-rich compost through their manure. And this essentially creates harvest and abundance. Food is harvested essentially, and then the scraps are returned to compost, to the chickens, and to black soldier fly bins. And the black soldier flies are really a powerhouse in this system because they convert a lot of waste that cannot be composted, such as heavy fats and oils, greasy foods, meats and dairy, things that aren't typically composted, and they basically convert that waste into black soldier fly larvae, which are a very high protein source and can constitute up to 20% of a chicken's diet. Food purchase, of course, will still be necessary, especially in the early years, but the black soldier fly and chicken interaction is really doing a lot of heavy lifting for this design. And so to actually implement this, we'll need our black soldier fly bins, which are very simple, but more importantly, we will need to design a coop and flock system. The coop, I have thought through a very thoughtful design that will include predator resistance. It'll be about 14 by 18 feet with as much automation as possible for feeders, waters, doors. It'll include a clean gravity-fed watering system, egg collection, easily accessible, a designated brooding area, a raised coop with a larger covered and closed shelter and run, strong predator prevention, deep litter bedding, which will be harvested as compost, and the run will open directly into those rotating free foraging areas, as I mentioned. And there will be a simple, streamlined flock management schedule. And once all of this is established, it should be fairly easy to maintain once the system is in place. So, that is the big heavy lifter for this design. And now that that is established, we can get into some more of the details with each of these four goals. So the first one is the closed loop chicken system. So let's see. The goal here is to leverage the natural behaviors that the chickens already do to close household waste loops while producing valuable goods and services. To do that, we'll build the coop and enclosed run, as I just mentioned. We'll supplement feed increasingly over time with things grown on site, as well as the black soldier flies. We will maintain an intentional egg and hatch plan, collecting eggs daily and using a select number of eggs each season to hatch. We will create and follow a cull schedule based on flock size and goals, and that will be to control the rooster ratio as well as have a meat harvest. And supporting the flock well-being and diet through rotational foraging, which ultimately benefits the chicken and the guilds and the rest of the site. It's a win-win for everyone. And the way we will implement this, a phased implementation where in year one, we will build the coop and run, establish our initial flock, and hatch the first round of chicks. In year two, we will increase the flock size through planned hatching, observe and respond to system feedback, which is something that I intend to always be doing, but particularly once systems are established. And in year two, there will be heavy focus on just seeing how things are working and responding accordingly. And year three, we will continue increasing the amount of feed that is produced on site. And the ultimate goal beyond these first few years is to have essentially a self-sustaining flock that produces consistent yields with minimal external output. So basically, if we can reduce the amount of grain and feed we have to buy, and the chickens continue to produce eggs and meat, that's the ideal goal. And so the next goal is to obtain near zero household waste. This is to build practical daily systems that divert household waste from the landfill into compost, chicken feed, and reusable materials. The approach is to assess the household waste streams and design practical systems for each one using the following waste stream logic. All organic matter, cardboard, paper should be composted. Meat and dairy scraps, other food scraps that cannot be composted should be given to black soldier fly bins. The chickens will convert select scraps and grains into their resources. And then things like packaging, jars, containers, building materials, things that can be repurposed or reused should be. It's really just about establishing the system so that the process, the daily routine is effortless. It's not something that we want to create a bunch of work in our daily lives. It's something that really the process should be very streamlined and effortless. We'll also assess, consumer habits, and reduce the purchase of goods that cannot be reused or repurposed. So really just thinking about what we're bringing onto the site and what the ultimate destiny of that product is going to be. Is it something that we will never be able to use again and it has to go to the landfill, or is there a future use for this product or the packaging that it comes in? And I think a really key part of this is to strengthen community. And rather than going out and buying a new tool for a project you might use once or twice, just talking to neighbors and local groups and seeing where there are opportunities to share, barter, or reuse. And also just collaborate within the community on innovative solutions for how we can fill the remaining waste gaps, which there will inevitably be. The implementation for this is year one to establish these routines and implement the black soldier fly bins. Year two is to refine these systems and continue reducing the waste streams, assessing where they're still coming in and addressing the gaps appropriately. Year three, the goal is to have negligible household landfill waste and begin working our way into community level impact and helping others to do the same. And beyond that, the goal would be to replicate this near zero waste model and essentially support the household to community scale transition of what we ideally will have accomplished within our own site and help people replicate that and scale it up to community level. So next, that brings us to building soil fertility for gardens and guilds, with the goal being to rapidly improve soil fertility and planting zones using wood chip drops, dense planting, chicken manure, and chop and drop. So the approach would be to source wood chips and apply a thick mulch layer on top of all planting patches. From there, planting, planting, and planting. Planting diverse and densely with special attention on fast-growing soil builders, nitrogen fixers, bioaccumulators, deep tap roots, ground cover, and all of the lovely allies that help us to build soil, using wood chips, compost, and native forest microbes to inoculate the soil and support fungal dominance in a healthy microbial ecosystem. Basically, we're looking out for our microbial friends, and we will be practicing chop and drop, especially during the growing season, to accelerate nutrient cycling and feed the soil. And as I've mentioned a few times now, collecting chicken manure and composting or aging it as needed and using that as a nutrient-rich amendment. The implementation for this will be year one, establish priority mulched areas. Year two, expand the mulch areas, add more support species, and continue intensive planting. Year one is also first round of soil building plants, first round of planting. Year two, more planting. Year three, refining the system to reduce the material and labor inputs. So, as with the other systems, we want to just be closing the loops and providing more of the inputs from within the site itself. And then beyond that, ideally, the soil system will be mature enough to maintain itself. And this brings us to our last goal, which is establish perennial food producing guilds. The goal here is to establish layered perennial guilds that provide food, habitat, and ecosystem services while requiring less maintenance and input over time. The approach is to, first of all, strategically design each guild based on the form, function, and plant requirements. Intentional guild design is definitely a very important part of this process. For this site, the goal is to establish 5 primary guilds, which are going to be organized by environmental tolerances and placed according to microclimates and water and light exposure. These guilds will include the palms, citrus, stone fruit, a drought-tolerant guild, and a shrub and berry guild. The implementation will be done in phases, where phase one is building soil, phase two is planting the trees as early as possible, and phase three is going to be planting out all of the support layers. And then we will, of course, harvest from the guilds as they produce and maintain them between seasons and as needed, with, of course, attention to temperature, water, nutrients, and pruning. The implementation will be year one, design the guilds, prepare the soil, establish ground cover, and plant primary trees. That's a lot, I know. Year one will be intense. Year two is to continue planting out the guilds, filling in support layers, observing and responding. Year three, the guilds will enter their productive phase, and regular harvest and seasonal maintenance will be needed at that point. Beyond that, the goal is to have a self-perpetuating and replicable perennial food system that produces a consistent yield. So those are the 4 overarching goals for this design. And now we will get into some other aspects of this project that informed the design. Here we have our stakeholder interview. This was conducted in order to get an idea of what the people who actually have a stake in this property and on this site, how they feel and what they might want to see included in the design. I had a very thorough conversation with Dina, who is the property owner as well as the primary stakeholder of this site. She has lived there for over 20 years, and I got an idea of what some of her visions, preferences, and just in general, what she would like to see incorporated in the design for this site. Some of her priorities, the top priorities are that she would like to have increased privacy from the neighbors. She would like a flexible shade or covering to be added to the existing patio that can be retractable. She would like to be able to grow vegetables using raised beds. She would like a small scale chicken system and to incorporate a water feature in the backyard, as well as to repurpose the wood that will be removed from the birch and cypress trees in her yard. There are a few ways that I incorporated these preferences and priorities into my design response. And those include by planting a living and edible fence and structural privacy elements all around the property line, having a porch greenhouse structure which provides shade and visual privacy, as well as, of course, a greenhouse. Um, Putting raised garden beds located in Zone 2 all around the house for ease of access and harvesting, integrating a chicken system which supports soil fertility and the garden beds, having a small water feature placed in the southeast corner, and on-site biomass reuse through hugelkultures, mulch, and structural elements. There are a few other stakeholders who include family members, Riley, Devin, and Jody, and their input informed long-term maintenance considerations like who can help out with all of these projects, daily rhythms, routines, and personal preferences. So these definitely informed the design process, and we'll continue on to see what else. So here is the base map for the site. You see here, we've got the main house and shed and well house structures. You've got your pavement structures, the driveway, sidewalks, patio, and road. You've got a few trees. You can see the elevation line around the outer edges of the map. And this, you see that we are at 14 feet above sea level in the South Louisiana property. And the site is very flat for the most part. You see we have a burn pile on the northeast corner where a lot of waste is burned. And beyond a few trees, you see birch, oak, cypress, a tallow, a Chinese tallow, and a magnolia near the house. And beyond these trees, most of the site is lawn and just open grass, open grassy lawn. So this is the base map. And let's continue on. So now we have the pre-design assessment of zones. So we have zones 0 through 4 for this site, where zone 0 is the most highly interacted with. It is the home. All of our daily life activities occur here. It is the core of this site. And then we have zone 1, which is the next most used sections that include the immediate backyard as well as the driveway. This is where lounging, driving, bird feeders are refilled, and there's a lot of bird watching here. A lot of, right now, just mental health, well-being, lounging sort of activities. Zone 2 is more infrequently used. It is a storage shed, requires minimal maintenance. It does have tools and supplies as well as the bird food to refill the feeders. And then we have zone 3, which is mostly the grassy lawn. The dogs do get to run here. It does get mowed weekly, but it is fairly infrequently used. Zone 4, we have a semi-wilderness woodline behind the house. This woodline does offer a lot of foraging opportunities, wild animals, wildlife, some predators, opportunities for hiking, and just a sense of nature connection as well. So in this assessment, you can see we definitely start with the core zone 0 and sort of expand out from there, but there's not a lot of interaction with outer parts of the yard. So as we move into the post-design assessment, which this is the zones after the design is applied, and we see in this post assessment, we see that the zones 1 and 2 are expanded significantly. And now zone 1 includes more of the backyard, it includes some of the front yard, and there will be much more frequent interactions here now. Zone 2 extends beyond Zone 1 to incorporate the majority of the yard at this point. And so, really, the biggest difference here is that Zone 1 and 2 incorporate more of the backyard, and that means more of the site will be incorporated into daily life cycles now. Daily cycles of living, daily habits. Zone 3 becomes contracted because the passive lawn that wasn't usually interacted with much is now being converted into more functional and utilized systems. Zone 0 and 4 remain mostly unchanged. So that is our zones of use pre and post design assessments. And next, that brings us to the site sector analysis. So these are the sectors of resources that influence the site. So let's start with first, you see the dense clay soil surrounding the house. This is because the house was built onto a clay pad. They laid clay all around the house to build the house pad. And so everything surrounding the house is very dense clay soil now. You have your low traffic street to the west. Yeah, this home is at the end of a neighborhood road and there's very little traffic, not too much to think about there. You have your semi-natural woodland to the east. As I just mentioned, this is a wood line behind the house. It is semi-natural because it has been cut down, cleared completely in the past, and now a lot of invasives exist there, such as Chinese tallow, which is the dominant tree, but also natives such as black willow, and herbs and herbal and medicinal plants exist back there as well. Let's see. So you get your intense year-round sun in essentially the southeast sector of the open yard here. And so, especially in the summer, of course, you get very hot, long sun days right here. You have your prevailing winds coming from the south, and there is hurricane season that, of course, in South Louisiana, we do experience. You have the neighbor sightline over here, which is what we will address in our design. And then in the southeast corner here, we have an area of the yard where water tends to pool. And that actually brings me to our next slide, which is the microclimate maps where we address this water corner. So the current conditions in the southwest corner of the backyard are that it holds standing water during rainy season. It alternates from very wet to very dry, and during those wet periods, it is a mosquito breeding area. Crawfish appear seasonally, and it is an existing habitat for other wildlife such as frogs, dragonflies, and a lot of wading birds come through. It remains shaded and protected from wind throughout the year. So this is a very damp and shaded microclimate, and the goal is to stabilize the corner by creating a small water feature that supports biodiversity and can capture excess runoff and be of assistance to the irrigation system that we set up. Okay, so the plans to achieve this, here first you can see the illustrated concept design for this water feature. And the steps to actually achieve this will be to first excavate a sloping basin that is about 120 square feet and about 2.5 feet at the deepest point. Lay down a liner with gravel on top to produce or to build the foundation. Then add water and install your aeration and pump system. Plant, 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 of course, diverse and dense, and then create microhabitats to encourage the local wildlife to use the feature. Plants that we will include are duckweed, irises, lilies, reeds, lotus, horsetail, elephant ears, willow, and these will all serve phytoremediation, microhabitat creation, and food sources. There are a lot of benefits to building something like this water feature, not to mention, of course, how beautiful and interesting and fun it'll be to have on the site as well as to build, but also it will significantly support and increase the wildlife presence and biodiversity. It'll be a place to store excess water runoff during rainy seasons and keep water on site. And it will enhance this um, microclimate and just support the overall ecosystem in this corner rather than having it be this rapidly alternating mosquito breeding corner. It can become a beautiful, ecologically supportive system. So that is the plan for this water feature corner, the southwest corner of the backyard, to basically be converted from this dry to wet, oops, from this alternating dry to wet patch that breeds mosquitoes at times to a stable water feature. So that brings us next to the site resources map. So we have a few resources that already exist on the site. As I've mentioned several times, we have the wood line that has plant matter, mulch, microbes, foraging opportunities, and native species. We have a tool shed with a variety of tools and equipment. We have 3 and 4, you see cypress tree and birch tree. These two need to be removed and the wood will be repurposed for hugelkulturs and potentially for furniture. 5, you see we have the well house, which is tapping the Chico Aquifer, and that is the water supply for the site. 6 is just referencing the weekly yard trimmings and the nitrogen-rich biomass, which is produced from that. And then 7, we have the burn pile, which produces wood ash and carbon. These are some of the resources we have on the site. And then locally, these are some of the resources we have within the community. So we have a local plant nursery at number 1. We have farmers market, which of course has produce and trading opportunities and much more. We have catfish or fishing opportunities for redfish, catfish, bass, trout, drum, all sorts of things. We have McNeese State University, which has lots of resources as a local college. We have the Burton Complex, which hosts the annual LSU Ag Center Plant and Seed Cell. We have a downtown market and festivals. There are a lot of community events that are held downtown. Creative Roots is a new local artist co-op, and they work with local herbalists, gardeners, and it's a great place for skill sharing, trading, all the things. Just a great community resource. And then a bit south of town, there are lots of duck and other seasonal hunting opportunities as well. So these are some of our local resources to the site. And that brings us next to the species that exist on this site. I created this species list, which includes the common names, the Latin name, the type of animal or plant or fungus or whatever it is, as well as the function and notes about this. The zone is not quite relevant here, but you see it's also broken into birds, mammals, amphibians, plants. So just some that stand out here. The painted bunting was a beautiful little bird that passed through for just a little while, and that was really cool. We had lots of hummingbirds migrating through as well. I've seen a bobcat in the backyard a few times. Lots of frogs and skinks and cute little amphibians. Lots of plants, of course. And then this list continues here. More plants. Some of them are cultivated plants that were planted on the site, not naturally existing there. We've got some fungi. I did not specify those to the species level because that's a big undertaking. We have the Louisiana crawfish, of course. It makes mounds all throughout the backyard, and many, many insect allies that are present on the property as well. So that brings us now to our analysis charts. This is a really fun section. So here on the left, you see an orthomosaic of the actual site that was created from drone captured aerial imagery. On the right, you see an example of a QGIS spatial analysis that I conducted. And I just want to talk a little bit about how I actually conducted the analysis and data collection for this project. So, aerial imagery of the site was collected using a drone. So, we basically captured data from the drone and then processed that data into a high resolution orthomosaic, which is what you see on the left. The orthomosaic was then imported into QGIS, where I was able to create an accurate site base map. So this is also scaled to reality and accurate to a very fine scale. And I created the base map and subsequent layers like the zone maps and performed spatial analysis such as tree spacing, coop dimensions, using QGIS in order to help inform some of the design decisions that you'll see in a bit. So this was some of the analysis that I did for this project. That brings us to our next analysis chart. This is a still evolving guild planning template. The idea is to be able to design your plant communities around a number of features. So once everything is completed here, because you can see I still have many columns that I will continue adding to over time, but the idea is that this will be a tool where you can essentially filter by maybe place in the canopy, water needs, habitat, harvest time, planting window, whatever it is that you are orienting your guilds around, you can filter with this spreadsheet and design your guilds based on a variety of factors, essentially. And it's incomplete now, but it is honestly a massive spreadsheet, and I feel like as I continue building this out, it will become a more and more greatly valuable tool that really enables some efficient guild planning. So you see I have fruits, fruiting vegetables, which are mostly garden elements. I have greens and then legumes, and this chart actually continues on into roots, herbs and flowers, and then specialty plants. You can see the herbs and flowers is very dynamic. That's going to be definitely a big part of any design that I do in the future. So yeah, that is the ever evolving guild planning template. Ultimately, I also hope to incorporate varieties and, let's say we're talking about blueberries and I know that one variety does well in Louisiana, but something else does well in Arkansas and something else does well, wherever. And to just include each of those bits of information over time. This is not, of course, something that will, I think, ever be complete, but it will be an ever growing and increasingly useful tool in the future. So that brings us next to my site assessment synopsis. So basically, I just thought about what some of the largest influencing factors on the site and the design, what those factors are. I've touched on some of these already, so let's talk about the soils. As I mentioned, there are heavy clay soils surrounding the house. Open grassy lawn covers most of the site. The solution is wood chips, planting, biomass production, and nutrient cycling. So a lot of the soil building that we already discussed. Waste, the existing conditions, most household waste currently gets sent to the landfill with some materials being burned in the burn pile. The solution is Dramatic renovation is needed to divert landfill waste. We will implement composting, chickens, black soldier fly systems, and reuse habits as mentioned in the mitigating household waste slide. Intense sun exposure is received across the majority of the backyard, and we will basically just be selecting plant placement, building our guilds, and placing them appropriately so that the drought-tolerant, sun-loving plants get the most sun exposure while the most sensitive plants are protected on the other side of the house. Prevailing winds from the south, hurricane season from June to November, and we will plant edible hedgerows on the south side of the site and keep tender plants on the north side. Existing conditions for water pools in the southeast corner, and the solution is to, of course, convert that into a water feature, which will increase biodiversity and wildlife support. And finally, that brings me to the final design. So here's a map of the final design, and we'll just go through this bit by bit. We've discussed a lot of this already, so I don't need to go into too much detail on some of these, but let's just start here along the edges of the property, both on the north and south borders. We will plant edible hedgerows with a lot of currants and berries. This will provide privacy, wind protection, and food production. So next, over here, we have our pecan tree. This will become an anchor in this corner of the yard and will grow to be very massive. It will provide a lot of shade and will be a very tall canopy layer. Ultimately, it will provide shade to the chickens, which are here. You see the chicken coop and run right next to the waste suite. This will include the black soldier fly bins as well as composting piles. And the placement of these is close enough to be integrated into daily life, but also far enough away from lounging areas and away from the home that it's not disruptive or disturbing from smell or noise. Here we have our kitchen garden, raised beds around the front and back porch, front of the house and back porch for ease of access and harvesting. We have our Palms Guild here in the front yard that includes pears and apples. This is a cooler part of the yard with less sun exposure, so these particular fruit trees will do better here than in the backyard. We see over here we have our berry guild along the wood line. It will include elderberries as well as some brambles. We have our stone fruit guild, which will consist of peaches and one apricot. We have our herb spiral plus cob bench. The herb spiral will be built out in the first couple of years, and the cob bench will be a year 3 implementation. We have our goddess trio, which is also the drought tolerant guild. It includes pomegranate, fig, and mulberry. And right next to that, we have the muscadine trellis archway. These 3 features, the herb spiral, the goddess trio, and the archway here, create this beautiful energy flow in the backyard that I think would be it would just offer a lot of beauty and immersion into the actual ecosystem that we're creating here. And the archway, you walk through that and it leads right to the water feature. As we discussed already, that will be its own element of beauty and wildlife and nature connection. And we'll have the black willow, the native black willow, propagated around the water feature as well. Over here, we have our citrus guild, which will include lemon, lime, and orange. And we'll also be receiving a bit of thermal mass heat from the home, as well as the most intense and direct sun year long at this spot. Next to that, we have our banana microclimate. So right here is a spot where the septic tank produces a bit of water at the surface. It is clean water, but it is it creates a wet patch by the house right here. So a banana microclimate would be really beneficial here to basically soak up and store much of that water and also create a moist and humid microclimate for particular plants that we might want to include in the design that might be a bit more tropical than what the rest of the site can support. So this banana microclimate will be a nice place to experiment with some of those more tropical plants. And then lastly, not quite last, but then we have our pollinator and experimental patch. This will be an area of the yard where we probably do a bit of chaos gardening, and plant a lot of flowers and kind of just scatter seeds and experiment and anything we want to try out, but aren't so sure how it might go. Anything like that will be done in this corner of the yard. Lots of experiments, lots of pollinator plants, and just a bit of a wild patch. And then now, finally, all around the property, we will have, as you see here, bird and bat houses that just support the overall ecosystem, biodiversity, ecosystem services provided by bats and birds. And yeah, that is a high level explanation of my final design for this site. And that now brings us to the implementation and maintenance plan. So, a lot of this has been covered, especially in the implementation for the four main goals that we discussed at the beginning. So, I'm just going to go through this at a high level as well. Year one priorities will be establishing healthy soil and doing the groundwork for a lot of the planting to come later, establishing chickens and black soldier fly systems, planting the first rounds of our guilds, establishing our waste and compost systems. And I haven't talked much about water propagation and seeds, but in year one, I would like to build a rain catchment system, just a very simple system that will allow us to harvest rainwater, as well as propagate black willow, the native black willow Salix nigra, from the woodline and propagate those, as well as begin collecting and cataloging seeds to form a seed library. That's a lot of work, but I think it is manageable and hopefully realistic. And then year two will be the water feature is a big priority for year two. And then planting out the guilds, just continue planting the guilds and developing the herb spiral. That's just acknowledging that in year one, all of those things will not get done. And year two will be largely about continuing and expanding upon the projects that we began in year one. We'll build infrastructure like the small greenhouse on the porch and begin installing the semi-permanent fencing structures for the rotational chicken foraging, as well as start creating irrigation systems. And that will be something that we work with the land and available resources and determine the most appropriate solution when that time comes. And that might be an evolving solution or a temporary solution that evolves into a more long-term resilient system. And I think another big thing to focus on in year two is communities and resource sharing, as well as, of course, continuing to refine the systems from year one, but also focusing on community networking and increasing reliance on trading, bartering, and resource sharing over consumerism. Now, year three will be, of course, continuing to refine those systems and finishing projects that were begun earlier in year one and two. by year 3, the willow trellis that we propagated from the native willow should be fairly well established to start growing muscadines. Year 3 will be for building the cob bench and the herb spiral. And then also, I think the kitchen gardens and raised beds would be a good thing to wait for year 3 to address because I feel that trying to focus on growing a lot of our food in the beginning adds more stress than practicality. So that's something that I would hold off for until our perennial systems are better established. Year 3 will also be for introducing value added goods, such as herbal products, dried herbs and herbal blends, tinctures and tonics, fire cider, and nutritional supplements. And then year 3 or even beyond, establishing an apiary to support pollination and honey production. So that is how we would actually build out and implement this design on this site. And now that brings us to the design evaluation strategy. So how would I actually evaluate the success of this design over time? My approach to that is to essentially spend a lot of time observing and interacting with the site itself. And through that observation, there are many indicators that will tell us about the performance and function and health of our ecosystem. And then taking those indicators and responding accordingly. And basically, that approach of observing, noticing indicators, and responding appropriately is how I plan to evaluate the design. So, some observations will include daily site walks, observing the plants, the chicken, compost pile, soil, and mulch layers, and really just being frequently present and immersed in the system, watching the birds, and inspecting all of the system components on a weekly or more frequent basis. Indicators that I look out for will include plant appearance, such as leaf color and turgor, growth rates and productivity, how well and how fast are things growing and how do they look, the soil moisture, texture, and color, chicken behavior, appearance, and growth rates, and native animal presence. So, what wildlife is coming, and are they using the supportive features we put out for them? And the responses to these indicators will include things like adding fertilizer or nutrients as needed, adjusting watering, plant spacing, or plant companions, adding mulch or compost, especially during peak production and seasonal transitions, closely inspecting and adjusting heat, light, food, and water for the chickens, and allocating resources to encourage or limit the desired wildlife presence. So that is how I plan to evaluate and respond to the design once it is implemented. And finally, that brings me to my personal assessment and self-evaluation for this project. So I'll read through some of this and we can reflect together. At the start of 2025, last year, I chose to leave graduate school and my position as a research scientist. I was reflecting on the year ahead and the direction I wanted my life to take, and I realized that research was not the path I really desired to be on. I felt a calling to land stewardship for some time, and I always thought it was something that I would pursue later in life as a retiree or once I could afford it. Thankfully, though, I realized it was something that I could pursue now. The choice to do that has reshaped my life path, and now I do feel deeply aligned with this work that I'm choosing to pursue. In hindsight, I am very grateful for the liminal period between making this decision and arriving to it, because it has created the space to prepare more intentionally for future land stewardship. This PDC gave me the structure to do exactly that. If my partner and I had purchased land immediately, I most likely would have moved straight into implementation rather than taking time to build a strong design foundation. Instead, now I feel confident in my ability to assess a site, develop a thoughtful design, and implement a plan to achieve desired ecosystem and stakeholder goals. When we do acquire our own property, I will be able to apply the systems and materials I've created through this course to our land, as they were all intentionally developed to be scalable and adaptable to a variety of sites. After completing this PDC course, I feel well equipped to steward land by designing systems that integrate human needs and daily rhythms with those of the surrounding ecosystem. I plan to work with existing site architecture, enhancing what is already present through practical and intentional efforts that strengthen the whole. My work will prioritize closing loops and creating systems that are interconnected, resilient, and scalable. In the future, I plan to apply what I have gained through this course to our own property and expand these skills into professional offerings. By combining aerial data capture, site analysis, and implementation consultations, I ultimately hope to contribute to a broader movement towards regenerative land-based living. Thank you so much for sitting with me through this and for listening to my design presentation. And as a little thank you, here are some of the lovely organisms present on the site that we are working with and that we discussed today. Thank you again so much, and wishing you the best.